Thank you. Thank you very much. I'm glad you like that. My name is Bradley Chapman. I'm a systems engineer from Los Angeles. I can't tell you who I work for because they'd probably kill me, but suffice it to say we have a really large and very complex network, and one of the challenges that I ran into when I started was that there was a DMZ and a proxy, and APNs was not working, and I made it a personal challenge for myself to get that working, so I had to do a lot of research to figure out exactly how APNs works. And one of the big hurdles that we have, of course, at a lot of companies is the network security teams and InfoSec. How do you explain to them how APNs works, at a protocol level and ports and services and everything? So I hope in the next 45 minutes to show you all of that. We've got a lot of information to cover here. So we've got the foundations of mobile device management, the protocol level breakdown of APNs, a look at the network infrastructure and the public infrastructure of APNs, some of the black holes. These are the pitfalls that will cause your push notifications not to work. And then we have some diagnostics that we can run on our systems to figure out how it works. So for those of you who have to send this to your bosses and they don't have 45 minutes to watch this, here's a quick breakdown of the 7 things they need to know about APNs. OK, there we go. So foundations of mobile, and I'll show you all of those again, don't worry about that. So foundations of mobile device management. First thing we need to understand is push notifications are very small packets of data that just contain instructions for that device. We all know about push notifications already. We have things like badges, banners, and alerts. But there's a second class of notifications that are silent. And these are things that don't necessarily have a user-facing component, but they do things that are important, like updating our apps in the background, letting our iPhones and iPads know that we have new music available, or when we publish a new device on HomeKit. There's also system-level services like Find My Friends, Find My iPhone, and mobile device management. So push notifications, they play an essential role in mobile device management. The building blocks of mobile device management, as we know, are DEP, configuration profiles, and management commands. So the first one, DEP. Jamf and IBM have made a big deal about this. It's the zero-touch, out-of-the-box, awesome experience for your end users. This is insanely convenient for them and also for you because you can customize the activation workflow, and your device is permanently associated with a management server, and you can do device supervision for maximum control and security policy enforcement. And when we talk about security policies, we deploy those with configuration profiles. These are triggered by a push notification. They're delivered instantly by your MDM server. They can also be used to set arbitrary plist settings if you need to. By the way, if you're still using managed preferences, you need to move to config profiles because they've been deprecated since Mountain Lion. There's a lot of things that are now unique to config profiles, like the list here. And the profiles cannot be removed by end users on DEP-enrolled and supervised devices. Lastly, and this is probably the most fun one, device management commands. They are triggered by a push notification. You can do things like changing the passcode on a device, enabling lost mode. You can lock and wipe iOS devices and Macs, and you can enforce iOS updates on a DEP-enrolled and supervised device. So the 3 things, DEP, config profiles, and management commands are the pillars of MDM. Now, let's talk about the protocol of APNs. So the other big concern we hear from InfoSec and network security is, is it secure at all? Because Apple's documentation and Jamf's documentation tell us we have to open up all these ports, but there's not really a clear breakdown of how it works. There's a chain of trust and multiple security factors in APNs. So your Jamf server has to have these 3 things: a certificate, a topic, and a token. The certificate. Most of us know about this one. You go to the Apple Push Certificates portal. You get your certificate, and then you can see some of the details like the serial number and then the UID, which I'll show you in a minute. So certificates are obtained through the Push Services portal. If you have a Jamf Nation account, you can do the certificate sign-in request really easily. You need to use an institutional Apple ID, and you have to renew it every year. The certificates are validated with public key infrastructure. That's basically verifying that a certificate is valid and trusted. You better use a public certificate for this. I don't have time to get into PKI, but there's a great talk by Ben Thomas from 2 JNUX ago about certificates. Highly recommend that if you want to learn more about PKI. Next, the topic. What is this? So if you take a look at the push certificate portal, there's a little detail right here. The UID starts with COM, Apple, and Management External. Every managed device is going to start with this. That is the topic. We're also going to see this in System Preferences in the profile. We scroll down here, and there it is right there. There's the server that's authorized to use MDM and the topic that it's linked to. Then the token. This is another one that's required for sending push notifications. This is a device-specific ID. It's unique to the device, but it is not the UDID. It's based on that and a couple of other factors. There's a unique token for each app. So if you have Facebook or Twitter or what have you, they all have their own unique token as well. It's generated by APNs and given to the device, and then it's immediately forwarded to your MDM server, so that server knows your device's ID and can send push notifications to it. They're regenerated after major system events like a reinstall or even backup and restore. So let's take a look now at the step-by-step analysis of the push notification protocol. We have seen many different diagrams of APNs. This is Jamf's diagram. This is one of Apple's diagrams. Here's some other service provider that tried to make sense of it. And then I don't know what's going on in that one, but it's Korean, so I can't read it anyway. But there are distinct sequences in the notification cycle, and so I'm going to show you all of them. They involve the device, the server, and APNs. The first part of this cycle involves communication between the device and APNs. And then we have the server talking to APNs. We have the device talking to our management server. We have the generation of the APNs topic and the token. And then finally, we have the actual sending of the notification, including the feedback loop in green. I know this looks like a football diagram, but I'm going to break it down in just a second. So, part one, device talking to APNs. The first thing every Apple device does out of the box, whether or not it is managed, is it goes to a server and asks for a bag file. How many in the room, show of hands, know about this bag file and have ever heard of it or seen it before? Okay, he's the only one raising his hand because he actually published a blog article on this. And it turns out that this is Franton, by the way, on the Slack channel. So what is this bag file that we're talking about? Your device is going to go to that URL right there. And it's going to grab a file that is a plist file that contains an embedded key, encoded certificates, and another plist buried inside of it that's encoded in base 64. And it contains all the parameters needed to communicate with APNs, like the actual courier host name. So let's say down the line, Apple wanted to change it to push feed, or like apns.push.apple.com or notifications.push.apple.com. They could change that. How many servers are available? It used to be that there were 200. Now there are 50 aliases. How to handle failover between Wi-Fi and cellular and so forth. So now what the device is going to do is go to the Apple push notification service and say, hi, I want to connect. It's going to respond and say, here's my certificate. Device is going to check that certificate, and then it's going to respond with its own certificate, which was hard-coded into the operating system. And then finally, they're going to say, we trust each other, let's set up the connection. Next, we go to the server side. It's going to reach out to Apple, and I want to point out right here, ports 2195 and 2196, these are both outbound connections. Your server reaching out to Apple. Even though we understand the primary feedback is inbound traffic from APNs, for firewall geeks, this is an outbound connection from your server. Same thing happens. We have a certificate exchange. Server checks it out, great. Your server sends the push certificate it got from Apple. Apple verifies that it's still good. Both sides trust each other, and we have a connection. Now we have device enrollment. So we already have a Mac that's talking to, or an iPhone that's talking to APNs, sends an enrollment request to the MDM server. MDM server responds with a configuration profile, and the device installs it, and it is now under management. The next thing that's going to happen is that device is going to say, hey, I've got a topic that I need to tell you about because I'm going to need to register for some push notifications. So Apple says, okay, here you go. Here's your token. Device says, great, thank you. It sends a copy up to the management server. Now, all that's in place. We want to send a push notification. So the first thing your server does is send a payload with the device token. That payload goes down to your device. It is stripped out, and now you have a JSON file with the actual instructions for that push notification. The next thing it does is sends feedback through APNs to your management server saying, hey, I got it. Cool. Now I'm going to execute it. And it can be anything from installing new wallpaper, setting up a Wi-Fi network, all the way to wiping the device. So that is the entire protocol sequence for APNs. Now here are the essential servers and ports that you need to know. We have your server will send notifications on gateway.push.apple.com port 2195. It's going to connect and await feedback on 2196. Your devices are going to go to the init server first, then hook up to one of the courier servers on 5223. 443 is a fallback for enrollment only, and initial activation, and when Wi-Fi, when 5223 is not available on Wi-Fi. Other than that, expect it to try 5223. And then there is a new API available for push notifications. Jamf's not using it currently, but it is something to look out for. So now we've seen the protocol cycle. Let's talk about the infrastructure for a bit. There's my water bottle. APNs is an always-on service, so devices have to be connected to receive notifications. So the first kinds of devices that we had that were push-capable were pagers, cell phones with SMS. That's a Nokia communicator, by the way, in case you didn't know. The BlackBerry was the first true push-capable device with email. And then you have Outlook 2003 SP2, where you got ActiveSync and the HTTP direct push, server direct push, I think it was called, where you could actually get push notifications on the desktop. But then there were these like not-so-smartphones that had some push capability, but not really native to the phone. So they had lots of apps that you can install, and if they needed to update themselves in the background, they did background polling. And this was absolutely murderous on battery life. So the recommended workaround at the time was to like go to the task manager and kill some process. But be careful, if you did the wrong one, you'd nuke your phone. So Apple was looking at all this and thinking, how could we make push notifications better? Well, we need to do 7 things. First of all, we need to make sure the battery life is excellent, that it's always connected, and that it's optimized for cellular. Back when the iPhone was first introduced, we still had 2G and edge networks, 144 kilobits maximum. It also had to give feedback when the push notification was received, and it needed to be extendable to apps and services on the phone, not just for email. But it also needed to be private and secure. And then finally, it needed to be available worldwide. So if we walk through the history of iPhone real quick, back in 2007, Steve Jobs walked on stage and prank ordered 4,000 lattes to go. That was the first that the world had ever seen of the iPhone. Then in iOS 2.0, the push notification service was announced, but there was no native MDM yet. You had to have an Exchange account, and you had to contact your administrator and say, wipe this device. And that's the only thing you could really do as far as mobile device management. Scott Forstall walked on stage at a press event 9 months later and said, there's so much demand for this service that we literally had to go back and re-engineer it from the ground up. ESPN SportsCenter was one of the biggest customers, and Disney wanted to do a lot with it. And Apple wasn't prepared for it. A lot of things with banners and sounds in that application. So they re-engineered it and reintroduced it at WWDC 2009. And then iOS 4 brought native MDM capability with some advanced features that weren't available with ActiveSync. Coincidentally, they had pushed 10 billion notifications through that service up to that point, just a year later. In 2011, you had iOS 5, and MDM was added to Lion. That was a big change for a lot of us in the industry. At that point, also, Scott Forstall announced that there were 100 billion push notifications that had gone through the service. 2 years later, iOS 7 with iCloud Activation Lock, 7.4 trillion push notifications. And unfortunately, this is the last public statistic for APNs that we have. So I did some extrapolation a little bit later on to figure out how many they've sent at this point. So then you have a couple of security updates. There was the Poodle vulnerability in 2014. Apple said in 1 week, we are cutting off access to SSL 3.0. You have to use TLS 1.1 if you're going to send push notifications. And then an engineer named Gokul Tirumalai walked on stage and introduced the new HTTP2 protocol. And at the same time, APNs now had to use TLS 1.2. And that brings us to today, where we're talking about the uses of push notifications and why it's important to MDM. Now, the APNs public infrastructure. This is something that, again, is not documented anywhere, but and I wanted to do some research to figure out like how vast and complex APNs really is. So it uses DNS load balancing strategies to ensure that the service is available worldwide. And again, I said before, I did some extrapolation based on publicly available figures. If you majored in statistics in college, I apologize. I took some liberties with R-squared and extrapolating from limited sets of data. But if you go out to present day, you could theorize that there's, with a logarithmic growth, that there's 40 quadrillion push notifications that have gone through the system. Again, this is a huge assumption, but it's still a lot of push notifications every day. So Apple needs massive infrastructure to handle the 1 billion devices that we do know about that they've talked about publicly. So there's trillions of notifications going through the service every single day. They have to have massive infrastructure to do this. There's only one company really that was capable of doing this, and that was Akamai. Now, Akamai has had a long partnership with Apple. Disclosure, I do not work for Akamai. This is just, again, research I was doing. They announced in '99 they had the QuickTime streaming function. 2003, they were agreed to provide the CDN for the iTunes Store. And now they do the global traffic management and fast DNS. That's part of the nuts and bolts of how push notifications work. There are 16 points of presence in the APNs system. In Akamai's language, and I think this is used by other global CDN companies, a point of presence is basically a host name that is providing a service. Akamai itself has thousands and thousands of points of presence. There are 16 of them in APNs, and they're scattered throughout the globe. The basic host name that we all know is courier.push.apple.com. But as I said before, there's a in the bag file, it says that there's a range of courier hosts that we might use, and that number is currently 0 through 50. So your device is actually going to randomly pick one of 50 courier hosts. So if you look at the debug logs for APNs, which I'll show you later how to do that, you'll see you might be connected to 18-courier.push.apple.com. But they all resolve, and depending on where you are in the world, they're all going to resolve to some combination of pop.courier.push-apple.com.acadns.net. So a DNS query on one of these guys returns 8 different IP addresses. These are constantly rotated, and they are location dependent. So depending on where you are in the world, you're not going to get the same one. And they are occasionally added and removed. I've seen about 300 or 400 different addresses coming out of the system since I ran this test in July. Do not whitelist static IP addresses for APNs. This will break, because APNs might use any address in that range. 17.000 through 17.255 triple, right? Okay, so why do we need to do this? Well, I like the analogy of Carl Sagan's Cosmos, where we talk about a cosmic calendar. You know, we start with a single IP address that's part of a subnet of 256 addresses. That subnet is part of a bigger subnet with 65,000 addresses. And that one is, you can have 256 of those. You get 16 million IP addresses. And there are 256 of those for a total of 4.2 billion IP addresses in the IPv4 space. And out of all of those, Apple owns the entire 17 subnet. So they have control of 16 million addresses. Now, how the hell did Apple get 16 million addresses, right? Because like, we've run out of IP addresses on the internet, right? So like, how did they get that many all to themselves? If you go way back to the beginning of the internet, when there was like nobody online in the 70s and 80s, and you know, educational institutions and DARPA, they just call each other up and say, hey, I've got a new server online, add it to your host file, right? Well, there's way too many freaking computers out there to do that with now, so they had to come up with DNS. In 1983, that was John Postel and a colleague of his that wrote the RFCs for DNS way back then. But The Internet Assigned Numbers Authority delegated the allocation of IP addresses for many, many years, and they still do. One of the things that happened is, and there's an engineer named Eric Fair who used to work for Apple, who participated in a Quora discussion about why MIT has a giant block of addresses, and he said they just asked. They literally just called somebody up at one of the network operations centers and said, I want to get this block. And Apple said, OK. Apple said, we want this. And so they said, OK, here you go. So they got the 17.8 block in April of 1990. And they've owned that since. They've never sold it and subleased it. In fact, there are a lot of companies out there that still have their legacy A networks here up here, like the Postal Service, DISA, AT&T, IBM, Level 3, Xerox, HP, even Prudential has theirs. So again, these are original owners. By the way, a little plug for the ARRL, that's the Amateur Radio Relay League. They do digital ham radio on the internet. It's pretty cool stuff. So Apple owns all of the IP addresses in the 17 block. They've never sold them or subleased them. And this might have been a concern a long time ago, but you maybe have some old school network engineers who worry about like spoofing, right? It's not possible because of three things. First of all, RFC 1771, the Border Gateway Protocol, version 4. And again, Border Gateway Protocol negotiates how autonomous systems negotiate with each other to route traffic on the internet. These are now protected and encrypted, right? With MD5, that's a basic hash sum. There may be an RFC beyond this, but that was the original spec for that one. Finally, ingress packet filtering. Ingress packet filtering guarantees that traffic leaving your network or coming into your network has a source or a destination IP address that is actually within the scope of that network. So many institutions already practice basic perimeter security anyway, so there's really no reason why traffic going to or from the 17 network would be going to anybody but Apple. Now, despite knowing all of that, we hit some black holes when we're trying to deploy APNs. He's nodding his head over here because he's hit one of these. So for APNs to function, your devices and your MDM servers must be able to connect to the 17 block on a limited number of ports. Let me say that again. They have to connect to the entire 17 block, outbound connections, on a limited number of ports. But the delivery of push notifications can be hampered by one of these 5 things: traditional firewalls, Jamf clusters, networks with a DMZ, next-generation firewalls, and SSL inspection. So, traditional firewalls. Most of us should know about these by now. If we have a device inside our network that wants us to communicate to the internet, we need to have an outbound rule. Conversely, if we have something on the internet that needs to reach a device in our network, we have to have an inbound rule. And if we need these services to talk to each other freely, we have a bidirectional rule. Now, directionality in terms of a firewall is from the most trusted network to the least trusted network. Once a connection has been permitted, it needs to stay open until it is closed by the client or server, or it times out. So we can't have a firewall that like opens the port once and shuts it. I've never seen that in practice, but I think I'd mention it just in case it's an edge case. APNs is always going to be outbound from your device or server to Apple. It's never, ever going to be an inbound, unsolicited connection. I'm going to say those things one more time. Outbound connections only, never inbound, never unsolicited. That is not how Apple rolls. If you have any questions about this, Jamf did update Article 34 recently with a full list of all of the ports and services that you would need for Jamf to work and also for APNs to work properly in your network. Second thing we have is Jamf clusters. Larger organizations that have thousands of devices may have 2 or 3 or more servers set up to receive client communication. In a Jamf cluster, you have 2 classes of push notifications. There's the ones that are sent now, which are like, they're sent from the JSS that triggers them. I know that's a dirty word, Jamf server. These are things like changes to config profiles and management commands. So if you have, let's say, a cluster with a node in the DMZ and a node internally, and your internal node is not allowed to access the internet, and you start making changes, you trigger that push notification, not going to go anywhere. Then there's some other kinds of push notifications that are sent by the designated master node in 5-minute batches by the MDM command queue monitor subroutine. This is part of Tomcat. This handles things like app updates, the classrooms, health systems, and DEP and VPP. Article 420 explains the role of master and children in clusters for Jamf. So again, I say the triggering JSS has to be able to reach the internet sans proxy. And the firewall, of course, would have to allow the outbound connections. So please put in some feature requests or go upvote the feature request to overhaul the cluster logic and improve the proxy support. Next, networks with a DMZ. Here's a typical network layout of a highly secure network at a company that has, let's say, a corporate network, a secure DMZ, a web DMZ, and the internet. You'll notice that the secure DMZ is walled off, so it can't reach the internet. The web DMZ network can reach the internet. Devices will communicate, let's say, through a load balancer to your access points, and the nodes will communicate into the secure DMZ, talking to your DB servers and memcache. Then you have maybe software distribution outside and inside because these clients can't reach the internet. And then you have everybody talking to APNs through a proxy. One missing thing here is that the client access servers inside, these are your Tomcat servers, are not currently connected to APNs. So you have to figure out how to get this to work, or a lot of this stuff won't work. So some tips and tricks for you. These are kind of workarounds. I don't like doing these, but you may have to. You have to ensure that all your Jamf nodes can reach the internet. But if they can't, one thing you can do is put your master node in the DMZ and edit all of your config profiles and do your device management pushes from the master DMZ. That will work, and it'll guarantee that they can reach the internet. And then you also may have to set an explicit HTTP and HTTPS proxy on your Mac. If you have a company proxy and you require the use of a PAC file to reach the internet, or WPAD, wireless proxy auto discovery, APNs will not work. It doesn't respect these, it doesn't understand these, only a web browser does. So if you're going to use APNs in a network like this, you have to set the proxies explicitly. And then if you need LDAP on the DMZ, you want to set up Infrastructure Manager. Article 174 explains how to deal with some of these things as well. So next-gen firewalls. We know about the traditional kind. Next-gen do things like inspecting packets on ingress and egress. They look at the pattern of the data to figure out, is this application allowed? Is this an application masquerading as something else on a different port, etc. Some of the industry buzzwords for things are App ID, that's the Palo Alto term. You've heard of Layer 7 filtering, and also deep packet inspection. So these things require a rule that are usually provided by the vendor, and most often you'll have to have a subscription to use this type of firewall. You need to double check those rules because they might be wrong. And in our case, they were incorrect, and they had been set that way for almost 2 years until I asked them to show me the rules. So for that case, we had to try a port-based rule to get APNs to work. So this is, again, a basic layer 3 rule. Allow from this network to this network on these ports using the TCP protocol. Something like that. It works. But if your vendor rules are good and you're sure that they work, then that'll be fine. Now, SSL inspection. This is kind of up and coming, and there's a couple firewall products out there that use this, but it's not well known, and nor the ramifications of this. So there's a couple types of things that you can do when you're analyzing traffic. You can use traditional packet sniffing, like Wireshark or Little Snitch, or a hardware device that's designed to intercept. Or you could do SSL inspection, but again, this is the kind of thing that I'm getting into as to what can be a problem for APNs. Packet sniffing, we know about this. It's used to monitor traffic. The things that you can see with APNs are the unencrypted sessions, like the device talking to the init server. That's actually how I discovered the bag file. You can see the TCP sequence of lots of different apps communicating. You can also see the different protocol stages of TLS. Client hello, server hello, client handshake, key exchange, etc. Then you can see the source and destination IP addresses and the ports that are in use. There's no impact to APNs just from monitoring traffic this way. SSL inspection, however, will terminate the encrypted session at the perimeter device, and the messages are decrypted, analyzed, and then re-encrypted with a different certificate. Not the one that Apple gave, but a different one. This is pretty much the same as a man-in-the-middle attack, and this will break APNs. So there's a thing you need to know about if your organization uses SSL inspection. You need to be aware of certificate pinning. What is this? So we have like a banking website that only requires that the session be encrypted, but they might not care where the certificate came from. But there are some applications that will check to see if the certificate coming from the client matches the certificate issued by the server. Google, Twitter, and Facebook all do this now, and they bundle their certificate with the Firefox and the Chrome browsers. Most Apple services, including APNs, use certificate pinning, so they'll be broken by SSL inspection. So what you need to do is be aware that Apple will reject traffic that's been re-encrypted with a different certificate, even if that certificate is trusted by a public root. Even if that certificate is trusted by a public certificate authority, Apple will reject it because it's no longer signed by an Apple cert, it's signed by a semantic cert or a thought cert or whatever. It has been altered or inspected. So your Jamf server and all APNs activity need to be whitelisted from SSL inspection. You've got to talk to your network security, your InfoSec teams about this, but they need to understand the ramifications of doing this. There's a couple of articles on the internet. I know you can't see those, they're really small. They will be available in the notes and in the keynote and the PDF online. One is from Symantec, that used to be a Blue Coat article that talks about certificate pinning. The other one is a blog article that explains how to deal with certificate pinning and getting your enterprise and your organization to understand the risks and the ramifications of using it. So now that we've seen the protocol and the infrastructure of APNs, we have some tools that we can use to verify that it's working at all. First place I would go to is your Jamf server debug logs. You go to /logging.html on your server after you've logged in. You enable the debug logs, and then you just download those. You can see all the APNs transactions. They're broken out. You can see the connection. You can see that the certificate's working or not, et cetera. So it's a lot of detail right there in the debug log. There's a few command line tools that you can use to test the functionality of DNS. NSLOOKUP or dig. You can just dig the courier server, and then you can even put an @ symbol and test it against another DNS server if you want to see the changes as APNs works in different parts of the world. Then if you want to check the ports being opened, you want to use Telnet. Telnet works on Windows and Mac, except for in High Sierra, they took Telnet out. You still have the NC or netcat command. So NC-Z server name, port number, and then that'll tell you if it's working or not. And then graphical applications for packet tracing are Little Snitch and Wireshark. So there's a couple of applications that you can use that are like out-of-the-box solutions for testing push notifications. Two Canoes makes push diagnostics, and AMSys makes services test. That's for the iPhone and iPad. One button, push, and will tell you if all your servers are connected, if your push notifications are going to go through or not. Now, if you're really into hardcore debugging, there is a command on the computer called APS control, APSCTL, and it's at that path right there, System Library Private Frameworks, Apple Push Service, APSCTL, and the only command you can run on it is status. And what this will do is it'll spit out hundreds and hundreds of lines in your terminal that show you all the servers you're connected to, all the apps that have tokens, whether the push notifications are working or not. So it is a good debugging tool if you want to see if like the MDM service is working or not, and you can look at it right there. So again, quick review. Here are the service ports for sending and receiving notifications, initializing the device, etc. Now I just have a couple final words to say about this. We have to remember that APNs is just a conduit for push notifications. It's not a command and control system. Apple has nothing to do with what goes through it. All they're doing is getting your application server to talk to your devices, running that app. So devices and servers will always make the first connection to APNs. APNs, again, does not require unsolicited inbound connections to your network. And the APNs payloads themselves have multiple checks in them to make sure that you're not a bogus or rogue actor sending push notifications trying to hack into your devices. So they have to match the certificate, the topic, and the token. Now, getting APNs to work in your network can be a tough fight for some people, but it doesn't have to be impossible. We want to make sure that the company understands the features and benefits of mobile device management, and that also you want to have some discussions to foster a willingness to accept the use of APNs in your environment. I know not everybody has this challenge, but this is geared for companies with high security networks or maybe stubborn InfoSec departments. So that's, again, the kind of thing that we're going for here. So make sure they understand how Apple works. You can talk about Intune if that makes them more comfortable. You want to make sure you have an open dialogue with InfoSec. Talk to them all the time. Make sure they understand the requirements. Get your leadership involved. And then finally, if all else fails, take them out for drinks. So that's my presentation. Questions?
Hi, Bradley.
Hi.
Kind of nervous because you did reference me a couple of times. Just on the topic of SSL inspection, one of the things that I've noticed with certain next-gen firewall products is that the process of the traffic going through the firewall will start with what's called a protocol detection before it then gets routed off to internally within the firewall, whatever it is using to do the traffic interception and monitoring.
Sure.
We found in my place that APNs is, because it's now using HTTP2, a lot of these devices don't recognize that protocol and just reject it. Is that something that you found as well?
So we don't actually use SSL inspection in our company yet. As I said, I spoke to a couple of people at different organizations that have it, and I've read white papers. I conceptually understand what's going on here, and I think in practice, you mentioned that it was breaking at your organization as well. So
yeah.
I thank you for that. That was good to at least get the confirmation that that was breaking. As far as the protocol-specific detection, yeah, because it looks like regular HTTP traffic, it's going to be difficult for these devices to even figure out, is this Apple push traffic or is this a web page, right? So again, that's probably going to be something where you want to look at the vendor, talk to the vendor and figure out, do they have a way to detect APNs or not? Another thing to remember is that the Jamf servers still use the binary protocol. That's why they have 2195 and 2196. They don't use the API yet on port 443, the HTTP2 one. So it may be a little easier now, only because they're high-numbered ports and they're very specific kinds of traffic. So.
Okay, thank you.
All right, yeah, thank you. Hey, Ben.
Hey, how you doing? You all right?
Good.
Yeah, just have you found reference anywhere as to what the content of the push notifications are? Because people do worry that, oh, you're going to send my wireless password across, and you're trying to say, well, it's not the profile, and just, again, security people can sometimes be a bit panicky about that.
Yeah, no, totally. So push notifications are, as I said earlier, a JSON file, which is a little text file, and it contains the device token in a alphanumeric string, and then it contains the actual instructions like display an alert or go to this URL. So if it was a push notification for MDM action, there'd be a URL inside this file that says go to this management server / computer / MDM / whatever the payload. So your Jamf server has prepared the profile ahead of time that needs to be downloaded by that device. So that single notification is only telling that device to do exactly one thing. The documentation for that is in the developer section of Apple's website, which doesn't require a subscription. You can Google that. There's also a specific section about the MDM protocol. So if you want to know how the MDM portion works with APNs, that's all there too. I have that in actually the appendix of this keynote, which is past the last slide. So if you download this from my webpage, you can get that, and I'll show you the link in a minute. But yeah, so the documentation is there to answer your question.
Awesome, thank you.
You're welcome. Hi.
Hey, how are you?
Good.
This is kind of might be more of a legal question, but around APNs. So in our business model, it doesn't make sense to set up a JSS for all the customers that we manage, because we don't have like a one-to-one relationship, which I think a lot of people using Jamf Pro, they do have that. And I've been going back and forth with a lot of other peers and people at Jamf about, I guess somewhere Apple technically says, unless that hardware is owned by the same business entity that the APNs is owned by, it's not legal, or you're not supposed to put that on other devices. Do you know anything about that?
I think you're thinking about DEP actually. So you have to purchase the hardware through Apple in order to use DEP and activate and enroll that device with DEP.
Right.
The actual enrollment in Jamf happens during the DEP workflow right at the very end.
Right. But if you weren't using DEP, just to push stuff.
You just enroll your machine, like user-initiated enrollment with the Quick Add package, or go to the website. The push notifications are possible whether it's DEP device or not. But you just need to enroll the Mac and make sure it says managed. If it's unmanaged, it won't It won't send anything.
Right, but have you heard of anything across multiple corporate entities using the same APNS?
Yeah, so APNS is a global service, so any device, every Mac is going to reach out to APNS for push notifications, whether or not they're enrolled. Mm-hmm. So like a New York Times breaking story pops up on your Mac because you're already connected to APNS. Right. But again, the MDM-specific payloads are only going to be sent by your Jamf server, so they would need to be enrolled in that Jamf server and then make sure they can connect to APNS.
Okay.
Does that answer your question?
Not really, but that's okay.
Oh, I'm sorry.
Yeah. Okay.
All right.
Do you want to talk after?
Yeah.
Okay.
Yeah.
Thanks.
Next question.
So this is kind of more like thinking like in the future. I mean, obviously, protocols get updated. It's TLS 1.1 and 1.2. Mm-hmm. Given kind of some of the black holes that you'd mentioned and some of the
Sure.
workarounds, do you see any opportunities for Apple to make changes or improvements with regards to all the handshake and whatnot to kind of, and if those changes were made, that would completely blow kind of everything that you're kind of talking about out of the water?
Yeah, it really would. I mean, I would love to be in the room where it happened and know when Apple's going to change this, but I'm not. So yeah, they could introduce something with iOS 12 that totally breaks or changes the way APNS works, and it just becomes a magical unicorn that transcends firewalls and makes you feel great every day. I don't know, but yeah, they could change it, and Jamf could change something that makes it easier to work as well. So yeah, we don't know.
Well, I guess I was also trying to touch on, in your research of this, have you found anything that's like, hey, maybe this should get fixed? Or,
in the last 2 or 3 years, nothing has changed. So the last significant change to APNS was what Gokul said about introducing the new API. That was aimed at app developers who are pushing billions of notifications out of their own apps, right? So HTTP 2 allows you to streamline multiple sessions at the same time, or parallel processing. But beyond that, nothing's changed in the last couple of years. So, but it remains to be seen.
All right, thank you.
Thanks for your question. Yes?
Hey, so you mentioned pack files.
Your name and your social security number?
You mentioned the pack file piece.
Yeah.
It's a complete no-go. APNS does not cross that or does not work with that.
It's because the APSD process, the APNS daemon, doesn't use it. It doesn't know how. The pack file was designed for web browsers.
So the alternative for when you have a DEP machine that has to talk to Apple when it's on a network that is proxied network would be
a dirty Wi-Fi network, what we call dirty Wi-Fi.
Right, but no proxy at all?
That is right.
Static?
Yeah, and in fact, it's in Apple's documentation that says you can't have a proxy. The other thing you're going to run into is if you have a Mac with the touch bar and it needs to do that firmware update for the Touch ID sensor, it needs to communicate to a network that is not proxied and also doesn't use 802.1x. So you can't even authenticate on a WPA2 network. You have to, literally has to be naked, WEP, WPA2, and open to the internet, no proxies. So yeah.
There's no alternative.
Yep. Not unless Apple changes something.
Thanks.
You're welcome. Yes?
Just a comment for him. We use Blue Coat proxy in pack files.
I'm so sorry.
You can whitelist it. You can whitelist. Thank you. But buy me drink later.
Okay.
You can whitelist it. So if you have the firewall rules in and you whitelist,
sure.
You can get APNS to go through.
Now, is yours a transparent proxy at the perimeter, or does it require a configured pack on the system?
Requires a configured pack. So you need to whitelist it and you need to disable SSL.
Next question I have for you is if your computer's sitting on the network and you do a DNS lookup for one of those courier servers, what do you get? Does your DNS do conditional forwarding?
That's a great question. I'm not sure.
Because what I think might be happening is your computer's able to look up courier.push.apple.com and it gets an IP address, but your network security might not allow that computer to reach the internet. Some networks have like this black hole where they send all unknown traffic into like a 1 dot whatever network, and then it just won't go anywhere. Because also they have conditional forwarding turned off on the DNS. So unless your DNS server knows to tell your devices about the Apple domain, it's going to return nothing in the answer section of a DNS query.
we have Apple whitelisted.
Okay.
So the 17 block in Apple.
Yeah. So that's like a routing and networking level where you allow the DNS lookup to happen at all,
Right.
and then your computers are able to route to it.
Yeah.
Yeah, that's going to fail horribly like in my environment because we have no external DNS message.
Wait, say that again. He said it's going to fail horribly in his environment because they have no external DNS resolution.
Sure.
So, yeah. All right.
I'm going to buy him a beer now.
Yeah, cool. So I think we're out of time, so just a couple quick mentions. The team at Jamf are Stam, Charles Edge, and Caitlin Schinkel, our marketing person. The big-time slackers, Joel Rennick, Mr. Franton, Richard Purves here, and Rich Troughton. And, of course, I have to thank the home team, my wife, and our cat, Pumpkin. Thank you very much. Here's my contact info. And if you have iOS 11, point your camera right there, get the QR. Oh my gosh, this is beautiful. I see like 100 phones coming out here. Thank you.